Hello, and thank you for taking the time to listen to this presentation. Having been a consultant, having worked in dozens of startups over the years, having been acquired a number of times and worked in large companies, I think I have a good broad sense of how people think about software. And I think this picture really depicts what it is. Each one of these dots, think of it like requirements or features or the software itself or pieces of the process. And we spent years and years just talking about like, how are these things shaped? How do they fit together? How do they work? We've talked about like the fact that there's this particular angle and we've measured it and we've created processes in which we can figure out these dots in closeness, and we've turned it around and we've noticed that there's holes and lighter spots and darker spots, but it's just a whole lot of complexity, and we've built tools to kind of not really deal with that complexity, but it's just a whole lot of complexity. And I don't have this view of software. I think when you step back and you look at it from one particular viewpoint, it becomes crystal clear. We're working on something that isn't what it is that we've been thinking about. There's order in that chaos. And I want to walk you through some of those ideas. This is a game that I use personally to help me think about this problem. The goal of the game is just simply to connect these dots such that none of the lines overlap and all of the boxes get filled. When you start working through this, much like when you're working through requirements in software, when you're trying to figure out how an API works and so forth, sometimes you just have to get started. You don't know how things interact. And once you've started, you realize, oh, that might not have been the right decision because I can't actually get this yellow dude over here. I can go this way, but then it blocks off orange. So it feels like I actually kind of have to refactor this. I have to take a step back and I have to draw this through here. And then even once that's done, as I'm bringing red around here, I realize, oh, I'm blocking off orange. So as I take a step back and I look at this, I have to actually think about these three things simultaneously. And I have green down here, which I haven't thought about yet. And to me, this is how software works. You have to keep the requirements in your head. You have to keep constraints of APIs in your head. You have to keep these language statements in your head. You have this big jumble of things, and it's a big jumble in your head. And sure, you have a document you can read, and you have documentation from an API, and you have your code that you have to read through. But even looking at this, even though I've quote unquote written down the code, and let's just go through here and loop this guy back. But even looking at this, in order to get orange through, I have to get rid of red. So I have to reset it in order to do this. And now I kind of forgot what I was thinking about with red already. And again, I think this is very much like software, where even once you've written down the language statement that is the thing that you want, if you have to refactor, you still have to keep all that in your head, and you still have to move it around and make it make sense. So what is software really? What are we doing when we're working with software? When you're writing requirements, when a developer is, again, looking at an API, when you're writing language statements, like what is that? What is the essence of what we're doing? And much like this game, there's just constraints. There's things that can and cannot be. What API is asynchronous and other ones not. You have to understand what constraints there are in the async one versus the non-async one and how you can put it together. And because I've made that decision, as I did here, I sometimes have to come back through and I have to refactor that decision because it's the wrong one. I have to pull back. And so again, leaving aside, like, what does it mean to write for loops and so forth? When I think about the pieces that I'm doing, all I'm dealing with is this world of constraints and decisions that I make, the implications of those decisions, those consequences of those decisions. So I want to look at this in a slightly different way. Let's look at it from an application perspective. So let's talk about a to-do application. So bearing in mind this notion of constraints and ideas and so forth, what kind of constraints? What are the moves that I can make in this game? If I want to create this to-do app, I have a couple of things I need to do. I can have let's add one. So I need a list of things that I have that should be done. And what's interesting is once I make that decision, then there's other decisions that I can make. Once I have a list of them, I can remove some of them. Or one of the main things that you do with a to-do list is you want to mark things as done. So how do we want to do that? Let's just say we cross out the text. And when you cross it off, it doesn't make sense for it to disappear. So let's just keep it on the screen. So in this case, as I go through, I can check these off, so to speak, and have them cross off. But that's actually not really what I want. I kind of want it both to check the box and cross them off. And again, these are some interesting sets of decisions that I have to do. I'm not writing any code at this point. I'm literally thinking about how do the components of the UI or the components of the storage or the components of the application as a whole, how do they come together and how do they interrelate? And let's say I want to add a new item. I can do it in a couple of different ways. And what's interesting, once you've done software enough, once you've done products enough, you realize that there's kind of things, there's defined ways that we do things. There's norms that we have that we try to follow so that somebody using the application can understand how it's done. So in this case, some of the normal things I might do is I might just have a new line that appears that I can write over it, or I can remove other ones if I want to add new ones. But let's make it easy and just add an input box. And when I do that, I have a whole bunch of new decisions that I have to make that correspond with that. So we have a placeholder. In this case, there's already a default, and I think that's fine. I can't just add new tasks yet, because where do they go when they get added? So where should they go? Should they go at the bottom of the list? So when we add a new test task, it goes to the bottom and we can check it off. Or maybe that's not what I want, and I have to actually see that to know what I want. But maybe I should go up here and maybe it goes to the top of the list. And maybe so that it's clear as to what this list is all about, let's put a title on it. Let's make sure it's got a name here. So let's call this Rob Studio app. Hopefully seeing here is much like those choose your own adventure books we had when we were growing up. You pick up the sword and should you try to attack the ogre? And it says, if so, turn to page 57. And you look forward to page 57 and you're like, oh, I died, so I shouldn't do that route. And it's kind of the same thing here. It's as low risk. I can make a decision like where do they go and what should they look like? And then that should tell me the consequences of those decisions. And what's interesting about software is that that's not something that happens, right? When you use an API, no one goes, oh, hey, if you go to the third step after that, you're gonna have to make this decision. But we know what those decisions are, or at least we know what those decision trees look like. And kind of expressing that in almost a similar but different way is same thing's true about layout. These things have to be within each other, and the list items have to be within the list box, and the text items have to be there. And if I change, say, the font size, that affects maybe that because this is larger, I don't want as much space between these two. So maybe I add less padding between the items or less padding between the top and the items. Let's say, for example, I do want less padding or more padding around the sides, less padding in between. And again, you think about the constraints of these things and how I have to think about them. Like if I don't have them, then I lose some of that spacing in between. And then what are the implications of those things? Software at its core is a set of decisions that have to be done. And it's surfacing those decisions and it's making them visible so that you know what the implications of those are. And just as we had in our example with the game, you don't necessarily always have a way to backtrack and keep those things in mind. And it seems pretty clear that we need easier ways to do that. And not just, for example, again, in code itself, but perhaps in a type of process like this. And my goal here is not to propose a new way of how we should create applications or create an application builder. It's, again, just really stripping away those frameworks and thinking about what software really is. So what is software really? Going back to that anamorphosis demo that I showed a few slides back, we're looking at all these dots. And again, as I said, those dots may be the requirements, or they might be an API, or they might be the language, or all these things. And we've just been spending all of our time just trying to figure out how all these dots interconnect. And we've never really focused on what software really is. And it's really a process about constraint discovery and satisfaction. Thinking back to that flow-free game that I showed you, it's just simply knowing, I know what the rules of the game are, quote unquote. And it seems odd that we've never really defined the rules of the software game. And these are the rules. It's really quite simple. I could go on for hours, but I'm going to leave a little bit of homework for you in this particular case. So at this surfacetension.ai, I've written basically a PhD thesis plus on this concept. I've gone through both in terms of prose as well as in terms of technology and tutorials and just different ways to go through this. I would encourage you to sit down and just take a read through some of the foundation material that I have, which kind of really starts with this introing surface tension. I called it surface tension because I thought it was an interesting play on words, thinking about the boundary, the constraint that is between atoms, between the air and the water, between all of the different components and what keeps them together. What I also really like about this slide, and we're going to move a little bit into talking about surfaces, and it's also a play on words. I really like the notion of surfaces. To me, the screen is a surface, or your phone, or really anything that you can present things on are surfaces. I've tried to bend a little bit the normal perspective of what slides are through some of the previous demos that I've just shown you. And what's really interesting here is when I was creating this slide, I had it do something that I've never really seen before within a slide, which is I had it scroll. And it's really weird when you think about it, because you've been in a web browser all your life and you're used to screen scrolling and all these other things. But when you're so used to seeing slides, and even if they animated things like that, you're so used to them being within the bounds. But this was just so interesting when I created this, the fact that it is this weird melding of slide, static, and surface, meaning show you anything. So I kind of wanted to do this transition between the notion of talking about constraints to kind of releasing our own mental constraints that we have about what is a slide and what is not. So again, in this case, I just really enjoy this particular slide as a transition. So I want to talk about anything machines for a moment. And I'll admit, most people have no idea what I'm talking about. They always ask, what is an anything machine? I'm like, well, it's something that can do anything. And they're like, well, what do you mean? And I'm like, well, what do you want? To me, an anything machine is a surface on which you can, like I just showed in the previous slide, show anything and do anything. You can make anything happen. It's infinitely adaptable. And the example that I came up with is the browser. What's amazing about browsers is that they're the perfect blend of nothing. So ignoring the Google default page that shows up in Chrome, when you open up your browser, it's just a white page. And it's fascinating because that white page can turn into anything. You can run, I'll just stick on the Google Suite for a moment. You can run a word processor in Google Docs, a spreadsheet. You can run slideshows. You can create movies and videos, and all of these things you're able to do through a browser. And I always just found it also interesting that we tend to still just do one thing. How many SaaSes do we have that just do one thing? Again, Google Docs does a document because at some point in the 60s, somebody said that word processing was a thing. We're still somehow stuck with that paradigm. And I just think that that's funny. So, but again, bringing back the point of, think about a browser. Think about, again, the browser is your desktop on your laptop. It's your screen. As you can see, it's controlling the whole thing. So think about this as, what can you do? Like, what are the bounds? What are the limitations? Again, what are the constraints? What's interesting is I have a whole other deck where I talk about this notion of the browser and surfaces and the internet and how it's changed. And so this is a slide I was working on, and just to show you, like, this, it's just, this is text, right? I can move my mouse over things. And what I really love about this is there was a really interesting transformation that we had a couple of months ago. We've all desperately wanted good text within images. And, when you're thinking about that, you're just thinking about the fact that you just naturally, when you want to draw something, you're drawing a picture and it's got text in it, you want that text not to be gibberish and so forth. But we kind of had an interesting, profound moment when GPT Image 1 came out. And again, I was working on this slide, and these are, again, all slides that I've created within this platform that we have. And we were spending time, because one of the things that I do as a small business owner, as a technology small business owner who's building an anything platform, is I have to run my business. So one of the things that I do in my business is I create slides. So one of the things that obviously my anything machine needs to do is help me create slides. So again, this is a slide I was creating for a presentation that I needed to give in support of the business that I run. That was the path we were on. And then GPT Image 1 again came out. And so what happened was I took this image basically that I had, and I took an image that I just found on the internet that I really liked with respect to, just an interesting combination of slide on one side, image, kind of breakdown thing. And I took the two together and I literally just handed it to GPT Image 1 with a little bit of a prompt. And it came up with this image. And it really caused me to stop for a minute. It gave me pause. So let me go to it. So this is the slide. Well, this is the image. The funny thing is that it's a slide. And what's fascinating about that is if you think about slides and you think about the way that you've thought about slides for most of your life, is that you can have a slide that shows an image. You can have a slide that contains images. What I'm really trying to get across to you is, again, this notion of surface and anything machine, which is we've had these preconceived notions of what slides are. You go in there, you type some text, you say add an image and do these things. But like that's over, it's done. As of GPT image 1 a few months ago, you can just give it some text and say like, create me the slide. And what's interesting about this is for me to actually create this slide as you see it in a standard tool, not as an image, would be really, really challenging. Because if you just look at the way that it's laid out, and specifically, I would say because of the way that the lighting, the cinematic effect of the lighting, even on the text. And sure, you could say you can apply a gradient on top. Like you know what the techniques are to do this. But again, the point is that I didn't have to do this. There's no point in creating, PowerPoint has no point anymore. Or even, let me go one more step further. Let me say, what is the difference between what happens in PowerPoint and what I just showed, which is, again, take some text, give it to an image generator and say, just make me a slide. And what's funny was this was literally the first one that I did. And I love it for that reason. I guess it's the one, why do you love your first child more than all the rest and all that kind of stuff, or your first car, or your first love and all this stuff. And to me, I love this one because one, I was working on a slide that was literally talking about how I think that the internet is going to be changing with time. And I don't think I'll get to that in this presentation, but I can do a whole other presentation on it. And again, the literal humor of the fact that I was literally talking about why are we still doing pages? And for this to be the first time that it just completely changed my concept of what a surface was, in this case, a surface of slides. And so let me go back to what I was saying, which is like, what is the difference between what you do in PowerPoint and this? And sure, you can say that you can go in and I can click and change the text and so forth, but let me move another slide and talk about that. Quick aside before I go in. I was recently watching the documentary on the linotype. I just threw this into GPT image 1 right after that, because while I know about the different components of typography, I wanted to see if it could just do something for me, create something visually and interesting for me. What I found first about this is that first and foremost is that it's beautiful. And that's fundamentally disruptive to me, because as a person who's dealt with developers for the past 30 years, if there's one thing that they do is they create really ugly things and you have to force them to make beautiful things. So the fact that this first came out with something beautiful was just fantastic to me. It actually gave me a little smile. And the second thing to note is, of course, like it's terribly wrong. It's missing everything. But if you squint at it, you kind of get the feel for where the future of this is going. Again, just the fact that as an individual, let's talk about the next generation of children, instead of like me having to have their mom and dad have them drive them to the library and take them and go through a card catalog and figure out where the encyclopedia was and go to the encyclopedia and look at something. The fact that I could just go to a surface, I can just say, hey, like, help me understand typography. And the fact that it could materialize this thing, and again, assume a few years in the future where it's correct and things like that. To me, that's really fascinating. So what I did next was I did the next obvious thing, given a background in software. I said, well, I want this thing to be interactive and correct. So like, what if I just went in and I turned this thing into an application, and I just got in here and I'm like, well, if I want to, get rid of a G or whatever, going back to the slide, for example, let me bend your brain a little bit. When we look at that slide, the first thing you say is, well, it's an image, not a slide. Okay, great. So what differentiates it from a slide? Well, I can go in and I can change the text. But if you think about that for a minute, for me to actually write the software that it is to put this beam at this point in this text, this is years of experience and work in order to get that to happen. I've got to have typefaces, I've got to have them split, I've got to deal with the kerning between them, and I have to know where the line goes, and I have to know how tall the line goes. And like, just the amount of work, like this is third, fourth, fifth year professional developer before you even get to the point where you really understand what the hell just happened. But if, again, going back a whole bunch of slides, and if we just tear all that away and we say, why? Well, we've built all these frameworks, we've built all this stuff so that it makes sense to us. But what are the actual constraints here? So if I just handed this to a machine and I said, hey, machine, draw a line. If I click on an O, try to draw it wherever, like I'm halfway, so it's on that side. I'm slightly more than halfway, so it's on that side. Like, tell me the constraint, help me build up the set of constraints such that you can just simply draw a line between these things. And when I press the delete key, respond to that action by simply taking everything that was to the right and move it to the left, or vice versa. And when you think about that, again, when you think about the software that we build, you just realize that we've built, like, again, this is like years of study in order to understand like how it is to build it. Sure, you can of course get a library today and build it, but again, just like the fundamentals of this thing. So going back to that slide and like, what's the difference between an image and a slide? And the point is again, that interactivity. And that interactivity normally meant that you write software. But I went to the next level and I just simply said, well, hey, machine, do something interesting with this. I had to do this. And there's something about this that is both fascinating and interesting and obvious and whatever. So let's dial it back for a moment. Let's just say, for me to do this, so I just said like you probably need to be 4 years in your career before you can put a freaking beam between letters and have them disappear on the screen. And again, I don't mean use a library. Again, I mean, if you had to do it by yourself, could you do it? What would it take? And it's massive. And for you to do this is incredible. To for example, to tessellate the letters, to turn them into something that you could then apply a physics simulation to, which implies that you don't even know what the hell a physics simulation is. And then to write that and to do that, like, to me, that is incredible, the amount of work that it would take in order to build this animation that you just saw. But on the flip side, all I did is I told the machine to make the text melt. It understands what it means by melt. Again, in an amazing world, it would say, well, how do you want it? What type of melting would you like? But in this case, it just picked it. But again, you can imagine a world in which it comes back and it's like, well, hey, here's 12 options. Like, is it this one, is it faster, slower, or something. But again, just looking at this, I was, with zero code, I was able to do a thing that would have been virtually impossible otherwise. And so what I want to hand you away is that it is not incomprehensible to picture a world in which you can, as long as you can generate frames at a frame rate such that it looks like a movie, which means on modern PCs and so forth, call it 30 to 60, maybe 120 if you're super fancy. But as long as you can get some type of neural net that generates images at that rate, there's no reason why, again, for example, it can't just put the line here when I click between these two letters, or that when I hit the delete key that I can't respond to that and literally redraw that surface for whatever it is that I need. So again, I hope that this has kind of melted your brain a little bit. Excuse the analogy and the pun and the visual. But again, to me, this is such a fundamental shift. The fact that that little thing goes gloop at the end, and I'll just admit, the way I did this was first frame, last frame. I simply took my first photograph, I pulled it to make a drippy version of the last photograph. I gave it to an image generator that just simply filled in the middle. And again, you could literally imagine that that's our future, that once we have AI that's just a little further from where we are right now, that you can give it a begin state and an end state. So again, if we go back just briefly for a moment, my initial state is this state. By clicking a key, it knows that the end state must be that the O disappears and the graphene moves over, that it could literally build the most beautiful animation between these two states by just simply filling in the blanks at a rate. And again, the fact that it can do this already today, obviously not in real time, but that's just a function of time and money and people's brain power. So again, what I'm trying to do here is in the first half of this, I talked about like, what is software? Like we spend all this time writing code in these things, and it's fundamentally a constraint process. And so we've been looking at this all wrong. And then at the same time, we just birthed this technology that fundamentally shifts the way we look at screen. Like, again, why in the holy hell would I ever write software, thousands and thousands of lines of code that allow me to delete the O or to make the letters melt when I can just tell the machine, like, go do that. So here's another example. I was working on this. I was trying to come up with new ideas for what our corporate homepage and things were like this. And this is basically the first version of it. It just I generated an image for the background. It did a just fantastic job. It did a few iterations, a few turns, and I got this. And then I added some text to it. And I'm like, well, I want to play with it a little bit. To which I said, well, wait a minute. Like, I can just tell the dude to allow me to play with it. So and obviously it's doing this programmatically today, but again, just squint your eyes for a moment and picture the fact that it doesn't generate code to do what it is that I'm going to do. Just picture that I click on this and it's like, oh, I know what I do when some jackass clicks on text. I have to show that it's selected. I have to show them indicators as to what to do. And so I can just then change that text and do whatever the heck I want with it. I can move it around and place it and move it. In this case, I can take this text and move it around. But again, I want to point out, I'm kind of saying three things simultaneously here. One of which is, hey, like, this is built on a platform that I'm dealing with. I just told the machine, hey, by the way, I want to be able to fiddle with this stuff. And it's like, okay, great. You can now fiddle with this thing that you're playing with, which is mind blowing. Second level of which this is like, hey, why can't we do this to everything that we see? You didn't know before I started moving things around, like maybe this thing it's not, but maybe this thing I can just pick it up and literally move it over. Like, why not? I probably could do it. I'll admit that the machine would be kind of bad at it right now. But again, in a realistic world, there's literally no reason why I just can't click this. It would show me a selection boundary like it does here. And I literally move it over. And it just simply generates the intermediate frames. But more practically, the reason this was interesting is they just showed me this on this surface. It's just like, here's some stuff to play with. Because I said, like, hey, I want to be able to change the color of stuff a little bit. So it's like, yeah, great. Of course you do. Like, here are the standard controls that one uses when one wants to play with things. So I can do this. I can add some color to it. I can add turn off the shadow. I can turn on a gradient. I can pick a couple of colors and say, go between the dark orange and the light orange. Oops, I forgot to turn it on. And so forth. And again, once I'm done with that, I can just simply tell whatever's controlling all these things. I can just get rid of the control. So again, just think about this world that we're headed towards, in which I didn't have to, in this case, there is code, but again, picture the last case where I just had to generate images. Picture a world in which I'm just like, okay, I just want to move this rocket over a little bit. And it would show me controls. And like I say, hey, I want to reduce the size of it. So it would show me something like this. And I would be able to shrink it down a little bit. It would know what shrinking means and so forth. So again, I'm hoping I'm showing you this future of the fact that writing code isn't it anymore. Because we can just ask the machine today to write the code for me. Of course, there's limitations, but what's the real goal here is, why is there code? Like, again, in what way, just like my melting text example, in what way did I need code to do that? So then, again, I just wanted to show yet another example of this, things that I just visually are fascinating. So this was, again, part of a slide deck that I was writing, and I was writing it as traditional slides. And once I created that previous slide that I showed you with, that was kind of the cinematic effect, we had gotten to this visual web is dead notion. And just to say, I firmly believe that this is true. Basically, once you start having agents that are operating on your behalf, then what the hell is a web page? Like, why does any B2B or B2C have a web page? It makes no sense. Like, I don't care what your web page looks like. My dude needs the information in order to give me what I need. So again, I was coming up with this, and I just had this picture in my head, and I just literally worked with my agents, which we have a platform called Charm IQ, and we call them charms, just as Google calls them gems. And I just said, like, hey, how should we think about this? And one of the ideas that we kind of came up with at the same time was, well, it should look like an obituary. And I'm just like, great, like, make it look like you just tore it out of a newspaper and it looked like an obituary. And what's so fascinating about this is, like, not that it was impossible in the past to have my designer come up with this thing, but the fact that I could just sit down and I can iterate through these ideas. And again, it would be amazing that I could just go in here and I could literally click on this N and I can start to type in that world. I could just say, because obviously this is too big, this should be much smaller than it is. And I would love to just click on this and say, hey, just as I did here, hey, give me a control and, like, let me see what the text looks like, bigger or smaller. Or I could just sit back and just say, hey, dude, like, hey, can you make the text smaller just gradually so I can tell you when to stop? And again, it's dealing with the constraints of the page, and it's dealing with these things. And as they move around, I would just say, hey, no, like make sure that the bottom text never moves and make sure the top text stays the same size. So again, I hope this just drives home the point of, and again, I love the fact that I was just so happened to be doing this on the point of saying the visual web is dead. It came up with these beautiful cinematic experiences. And just to really just kind of tie this whole notion home, my biggest statement today is all about ephemeral applications, that something should only exist as long as you need it. It should shape what you needed. So in the previous example where I showed you those controls, they should just appear when I need them. Like all applications don't need controls. Somebody doesn't have to code them up. It should just appear as I need it and just disappear when it's not. And so I think we're headed into this really interesting world where, as we lose the scarcity notion of having to build things and time that's spent with developers and things like that, it's more important to think about how things change and what the impact of those changes are and how they can change, which again leads back through my whole presentation about there are constraints around those things. I can't both say delete these letters and say it still says information. Like there are things that are just contradictory, that there has to be constraints underlying all these things. And we need to get our LLMs and all the future manifestations of this thing to understand what these constraints are and whether they're built from the real world or whether they're trained in and whatnot. I think that, again, hopefully you see this path through here. All I want to do is just quickly show you that everything that I've been demonstrating is in this platform that we have. So think of it like Google Docs. So I can just go in here and I can do whatever I want, including slides and everything else. To me, it's an anything machine. It does whatever I want. Why do we have a separate word processor, spreadsheet, slides, etc.? I have no idea, but it is what we do. So, but in our case, we don't. So this shows, here's your slide overview, just as if you're in PowerPoint or whatever. You have all of your slides just work the way that you just go to that section. And again, this is just all text. So I can go in here and I can talk to these things and type around and so forth. And again, I can also have applications built in them. So whether there's applications or not, or again, all these things are live and I can play with them. And because why not? Like why shouldn't I have the ability to have my ephemeral applications within here? And just to give you a really quick demo. So that anamorphosis slide that I had showed you up here earlier, which again is just always fascinating to people when I show them that. But so this came from, I'd seen some of Michael Murphy's art a long time ago, and this like completely coalesced the way that I was thinking. And so I just always loved this idea. So I went online and I just basically grabbed a halftone image. And what's amazing again about now is I just told my dude, I'm like, hey dude, I need to be able to cut up this image up into little squares. So I had to build me an application. Again, just took about a minute to do these days. So you can look at this. I was able to draw the grid such that each cell fits in the grid, and then I can see and make sure that each of the halftone dots fits within its own grid, and then I can have the application pull those things apart. So then I built a second application so that I could start to play with some of the parameters and see how much zoom in and zoom out that I wanted, whether I want to have perspective correction and what does that do and what does that mean. And again, to try to do this stuff in code just seems so dumb, right? I just need it to surface, and I'll keep using that word in lots of different ways, but I just need to surface the controls that I need in order to get this thing done. So I can look at whether the dot should be filled more, or if I should, again, just like all of the different controls that I needed in order to get it to look the way that I wanted to. And then I was able to pick the initial setting that I wanted and figure out the camera rotation and everything else. And then once I had those settings, I'm just like, hey, dude, give me the rest of the thing. We came up with a picture for the way this thing looks. And I said, go build it.